In this video, we're going to learn how to model with linear equations. So first question here, triple a number minus 7 is equal to 8. What is the number? Well, why don't we set up a linear equation to solve this? So first of all, a number. Why don't we set x to be that number? X can be the number. So that's the thing that we want to solve for. So now let's set up an equation that we can use to solve for x. First of all, triple a number. Triple a number means 3 times the number. So let's write that here. 3 times x. Alright, next part of the equation will be the minus 7. Triple a number minus 7. So 3x minus 7. And that is equal to 8. So that's what we set the equation equal to. 3x minus 7 is equal to 8. Now it's just a matter of solving this equation. So let's go ahead and do that. Let's add 7 to both sides. That way it'll cancel out that minus 7. And we get 3x is equal to 8 plus 7, which is 15. Now we can divide both sides by 3 to get rid of that 3 in front of the x. And then we just have x is equal to 15 divided by 3, which is 5. So there we go. There's the number. The number is 5. Alright, here's another problem. It costs $30 plus $14 an hour to rent a moving van. Cynthia's bill was $100. For how many hours did she rent the moving van? Alright, so this is going to be a problem that we can again use a linear equation to solve. First of all, let's assign our variable. How many hours? Let's let that be x. So x equals number of hours. Now let's set up our equation that we can use to solve for x. First of all, we're told that it costs $30. So let's put that in our equation. We're starting with $30 of the price. Then it's plus $14 an hour. Alright, so that's plus $14 times the number of hours, and x is the number of hours, so plus 14x. Lastly, the total bill was $100, so that means this price here has to be equal to $100. And based on this information, we've got an equation that we can use to solve for x. So let's go ahead and do that. Let's subtract 30 from both sides. That'll get just the 14x alone on this side. So we get 14x is equal to 100 minus 30, that's 70. Now we can just divide by 14 to get the x alone. Do that to both sides. That cancels out the 14 on the x, so we just have x is equal to 70 divided by 14, which is 5. So x equals 5, and that means she rented the moving van for 5 hours. Alright, final problem. Jack went shopping with a budget. He found a pair of pants with a half-off discount and thus has $30 left to spend on a shirt. If the pants hadn't been on discount, then Jack would have only been able to spend $10 on a shirt. How much did the pants cost before the discount? So in this problem, we're trying to find the cost before the discount. And the cost before the discount, why don't we just let that be the letter x? X will be the variable, that's the cost before discount. Alright, now let's look back to the problem to set up an equation. So first of all, we're told that he's found the pair of pants with the half off discount. So first of all, how much money is that? Well, that's a half of the cost before discount. That's a half off. So make that a half times x. And thus he has $30 left to spend on the shirt. So a half x plus $30 is all the money that he would spend if he bought a shirt for $30. Now that's got to be the same amount of money in the other scenario, which involves the pants not being on discount and then only spending $10 on a shirt. So how much would he be spending in that scenario? Why don't we write down an expression to represent that? So if the pants hadn't been on discount, then he'd be paying the full price for the pants, the cost before the discount. So we just have x, and then he would have only spent $10 on a shirt. which means only $10 would have been added to the total bill. Alright, great, so now we've got an equation that we can solve. So why don't we solve it? Let's first get x on one side. Why don't we get it on this right-hand side, because 1x is bigger than a half x, and we always like to subtract smaller numbers from bigger numbers. So subtract a half x from both sides, and what do we get? Well, that cancels out this side, so we just have 30. 30 is equal to x minus a half x. So 1x minus a half x is just a half x, and then we still have plus 10 on that side. Now let's get a half x alone. Let's subtract 10 from both sides. Minus 10, minus 10. The result there, minus 10 cancels the plus 10. We've just got equal to a half x on this side, and then 30 minus 10 is 20. Now to get rid of the half, we can just multiply by 2 times 2 on both sides. And what do we have? Well, 20 times 2 is 40, and then a half cancels with that times 2, and then we just have x. So 40 equals x. That means the cost before discount was $40. Now we know how to model word problems with linear equations, and in the future we'll continue to learn how to use our knowledge of algebra to solve word problems, including problems involving consecutive integers.